Hi, my name is Lindsay Gold, and I'm from the University of Dayton in Dayton, Ohio, and I teach the math methods for early childhood majors as well as the graduate educational technology courses. And I'm here with my good friend Rachel, and I'll let her introduce herself.
Hi, everyone. I'm Rachel Gorsuch. I teach at Columbus Academy in Columbus, Ohio. And this year I have the awesome opportunity to teach AP Statistics and Advanced Geometry. But throughout my teaching career, I've taught 7th grade math, 8th grade math, Algebra 1, Geometry, Algebra 2, Pre-Calc, the whole slew of classes. And then I also taught a physics class. So to the stuff that I'm sharing with you today, I'm excited to share all of these different classes that you can use statistics in.
Thanks, Rachel. You have so many good experiences, so we are very lucky to have you. Tonight, we're going to be talking about statistics and data, specifically the process of statistics, representing and interpreting data, ways students can use statistics to draw conclusions and make informed decisions. And I'm going to be focusing on the elementary part and using the TI-Nspire CX app for iPad. Whereas Rachel is going to handle the middle and high school, and she has all kinds of technology to show you. We have the TI-30XS, the TI-84 plus CE, and the TI-Nspire CX Premium teacher software. So lots of variety and very exciting. I'm going to begin by sharing my screen here, and it just takes a couple seconds to flip over. Okay. So the first thing we're going to talk about when thinking about statistics, I think of what is called the GAZE report. It's Guidelines for Assessment and Instruction in Statistics Education. And so I use this when I'm talking to my pre-service teachers about the things that we want to really make sure that we're focusing on with statistics, such as at the elementary level, formulating questions, collecting data, analyzing data, and interpreting the results. So the 4 basic ideas for statistics is what we use at elementary. Now, the GAZE report is pretty cool because it's a developmental process, which I think is really nice. They have 3 levels, level A, B, and C, and they're not necessarily equated to grade levels, but rather the student's development and statistical literacy. So a lot of times we'll see that students in elementary through high school are level A and B, and then level C kind of usually happens after high school, but it's really developmental rather than per grade level. But things we can do with elementary students is I'll pose a problem to them. So here's their problem. The pet store is not sure how much pet food to keep in stock. Your task is to help find out what kind of pets people own so that the store can know how much food to supply. So we kind of talk about this, and Rachel, feel free to, throw in some ideas if you would have questions, or what do you think about when you see this problem? Is there anything specific you think about or that comes to mind?
So when I look at this, first of all, I love it because you've chosen something that the kids can really care about. If they have a pet, they probably love them a lot and they've learned to be responsible. And so they know all about they have to feed their pet. And so first of all, I think it's a really engaging question, and they're going to have a lot of questions to formulate with you, the teacher, for this. So for the content matter, I think really matters when we're talking to kids, because we want something near and dear to their hearts, and then they'll just run with it. So I think it's a great question.
Thanks. And that's what I hope with pets. I know I personally am completely in love with my pets, a little bit obsessed maybe. So that's why I kind of thought of this. And so we would talk about, different aspects of the problem, but we would come as an example with a question: which animal do you have for a pet? Because the store really needs to know, how much food should we be supplying? And to find that, we got to find out what kind of pets people have. So then we talk about how can we collect this data? And a lot of times at the elementary level, that is looking at a survey. And frequently we narrow it down because especially students might have everything and anything for a pet. So we're trying to narrow the choices down a little bit. So we are giving the choice of cat, dog, fish, pig, or other. Because you never know. I grew up in a farming community. That could lead to all kinds of different pets. So I threw in the pig there as well. So when students are collecting this data, this is an example of what we see a lot. So they'll start, here are my pets, here are my choices, and they'll do tally marks. Tally marks are frequently practiced at the elementary level. And so in this case, they have their paper and their tally marks. But what I think is cool with this technology is that we could throw in a spreadsheet. And so here I have 13 students in my class. It's a small class. And I did some makeup data here. So for instance, student 1 had a dog and a cat. And then student 2 had a cat and an other, and so on. So they had the opportunity to collect and then organize their data. So over here on the side, we see that there were 5 people or 5 cats, 6 dogs, 4 fish, 1 pig, and 4 others. So just another tool of technology that students could use here is to collect their data using a spreadsheet.
And Lindsay,
oh yes, go ahead.
I just want to interject. As a high school teacher, I love seeing spreadsheets and lists in this way in the lower grades. A lot of people, I think that this is a far reach for a younger child, but really they're used to making tables and they're used to putting maybe what their animals are on like little cards and arranging them on little cards. And this is just another way of showing them how we could arrange something in a table and then reorganize it to make better sense of it. And that's a huge part of what we want to do with statistics and data collection is, yes, I have a lot of raw data, but how are people going to want to see it to best understand it? So I think that this looks awesome.
Exactly. And really, they are good with the technology. Sometimes we underestimate them, but these elementary kiddos, I swear they're born with it. The digital natives, as they're called, because they do such a nice job. All right, so we have our data. Now we have to decide how do we want to represent that data. So this is where we come into the standards of a line plot. And as a teacher and as a professor, I've looked into this a lot. What is a line plot? And even Rachel and I talked about this in planning for this webinar. What does that look like? So in elementary, the line plot is basically a way to show data using a number line. Sometimes we use dots specifically, so then people can refer that as a dot plot. But a lot of times we use X's or other representations to show on the number line. And Rachel, you can kind of talk about the vocabulary. What do you see as a line plot?
A lot of times when I read the statistics books for this high school level, a lot of them are saying that a line plot is similar to a dot plot. It's just a line going straight up. But the whole thing about it that's a little confusing is that if you get onto something like Google Sheets or Excel, they also have something called a line graph, which is playing connect the dots on a scatter plot. So I'll be honest with you, I step away from line plot unless I have a specific curriculum that wants me to use that vocab, because I think dot plot is a much better way to talk about it. I know that the line plot is in the standards, but dot plots really help students identify that each individual piece of data is being counted. Whereas a line plot, if you're just drawing a straight up line, you kind of lose that discrete nature of it. So those are like just my personal thoughts on it. I love the term dot plot, and I think a lot of us at the high school level think that that's a great starting place for students to come into the idea of representing statistics is with a dot plot.
Thanks. So yeah, this is one of those vocabulary things we need to keep thinking about and deciding how do we want to word that. So with this, oops, excuse me, I went one too far. This is what you usually see at the elementary level. So we have our pets and we have listed cat, dog, fish, pig, and other, and then we make our X's to represent how many of each animal. And so the good thing about this is you can still interpret the data, you can still look at it, you can, see that a cat, there's 5, you can see, that pig is the least, those kinds of things. But with this particular software, I like making it a little bit more interactive. And here, what I would do is I would call the students up and they could choose their animal. So we found from our data collection that there were 5 cats. So to choose that, all they have to do is click on the up arrow of the slider. And I like that it's up and down versus side to side because that's what it looks like to them. So they can add their animals to each one of these categories. So we have our cat, there were 5, there were 6 dogs, there were 4 fish, and there was a pig, and there were 4 others. And so why I really like this software is that it's a lot more interactive, it's a lot more engaging, the students can see and manipulate it, we can still make inferences and still talk about it, but what's nice is that we can take it a step further. So this was our data collection, but then we can do what ifs. Whereas if you're using the other one, I can't go backwards per se. I can't eliminate, 2 fish without it looking like I've just, scribbled on my dot plot or my line plot. So that's another reason why I really like this software. So after we've done that and we've represented, we have our graphical representation. So this is taking us back to our list that we had. So we have, our pets, our students, our pets, those kinds of things. But I added a couple columns here. So I have the number of pets. And what's really nice about this is those numbers changed as I added them to the line plot. So you can see the cat, the dog, the fish, the pig, the other. You can see in G that the total was 20. You can see the percentage of each one of those. So this could be taken a step further with students if you wanted to work on fractions and decimals and percents to see how many of each animal there was. So I'll go back for a moment to show you once again. So this was our original data. But we could go and we could start to change things. And then if you look back then to our spreadsheet, those numbers have changed. And so our percentages have changed, our total has changed, all that has changed. So just another reason why I'm loving using this kind of software with my students, my younger students, because they have the opportunity to, as I like to say, play with it and explore, which I think is so powerful. So after we've done that, and we start interpreting the results, here we have, the analysis, but we want to relate it back to the original question. So going to our data again, one more time, we see, and I'm going to put it back to what it was at the beginning. Okay, we see that there are 5 cats, 6 dogs, 4 fish, 1 pig, and 4 others. So I would talk to the students about which animal had the most. And then we could talk about, oh, it was a dog. And which animal had the least? Well, it was a pig. So if we're thinking about the original question of how much food that the store needs to supply, I would talk to them about, okay, so which type of food are they going to need the most of? And so we could see that it's dog, but then I could talk about the cat is only one difference. So it's almost the same amount of food that we would need for a cat and the dog. And the pig, we really don't need to buy as much food, pig food, because we don't have many pigs per se. But another thing that I would talk to the students about is the other. So what do you do about that? So that might be another type of data collection that we need to look at, is what is the other? Because if I were the store, I'd want to make sure that I had everything I needed. So here, just to reiterate, the animal owned the most by students is the dog, although the cat is close second. And then they could see that students owned other animals as much as the fish, so those were equal. We could talk about, we could throw in some how many more, how many less, those kinds of things to practice our addition and subtraction skills. There's so much we could do with the fractions, the decimals, the percents, those kinds of things. We talked a little bit about needing more information on the other animals, and then the small amount of pig food. So that relates it back to the original question. And then we kind of see what we need to do from there. And that was something, Rachel, you were talking about, the importance of statistics and, you know, really analyzing that data. Did you have anything you wanted to add to that part?
Well, I just want to take a moment to talk about so many of us who love using technology and love teaching math. We also, of course, love our students. And I think this shows that there are lots of ways in a math class to really get to know your students through doing math. So the fact that you did this about something they're passionate about, their animals, and something that they love, their animals, you're giving them an opportunity to share about themselves and to have that open door to see how math directly relates to something that they care about. And I think that that's just so important. And what the technology does is it gives you kind of that quickness in adapting it, so you're not like writing on the board and then having to run back to your seat. It just like gives you a little more speed and still the same amount of precision. And so more time can be spent in the classroom hearing those students talk about something that they're excited about, which is their dog. And then once that part of their brain is up and running, and the math part is like just sitting there waiting for them, they're reaching for it because they realize that that math can help them better care for something that they love. So I just think that the pairing of getting to know your students with this intentional math concept, I think it's a great way to help students see a way to love math because it affects something that they're passionate about.
Well, thank you. I totally agree. The more purposeful we can make it, the better, because as you said, then they relate to it, but we're also relating to our students and their interests. One more thing that I wanted to show you is another type of graph that we do a lot, and this is a bar graph. So you can see, you know, I wanted to know how my students got home from school, whether it was bus, walk, pick up, or stay after. And so in this case, once again, it goes back to, we have our bar graph, we can analyze, we can, you know, compare, those kinds of things. But this is one day, one snapshot. What I like is the opportunity here is where teachers can collect this data every day. So students could come in and choose, are you going to be a bus person, a walk person, a pickup person, stay after? Because it could depend. Like if there's a club and they need to stay after, then that would apply. But that can change. Another way teachers could use this kind of format is like a lunch count, those kinds of things. So once again, we're still making it purposeful, and it's still applying the statistics and what we're learning and the graphing and the data to the students' actual day, and they're seeing what they need. So say we have 4 bus riders, and once again, this works the same way. But the cool thing about this one is that I can use my up arrow and my bar grows, but it's a split screen. So I split it with the spreadsheet. So here we can kind of see underneath, as the bar grows, it tells us how many students. So we have 4 bus riders today, and we have 6 walkers, and 2 students are being picked up, and 3 are staying after for the clubs. So once again, they can look and they can see, well, most students or more students will be walking than bus riding, picking up, staying after. But what if we add those together? So what if we added our bus riders, our pickup people, our stay after? Is walking still the most? So we can start, combining categories, talking about the different categories, looking at what the students are doing daily. Once again, I like this because we can change it. My other paper graph, bar graph, once it's done, it's done. I mean, I could add to it, but it's not nearly as pretty. So here I can be changing things as the students change their activities. And so I think once again that's really nice. It's a nice way for the students to engage in the graph, engage in the data, but also there's so many different things you can do with this, whether it be how students go home from school, the lunch count, all kinds of things that teachers collect daily. We collect this data daily, so we might as well do so in a way that the students see how we use it and how it's purposeful.
Well, and
So
Lindsay,
yes.
you just gave me a thought too. Like as I was watching this and you were talking about how the paper, like once you're done with it, you're just done and it goes away. One thing that I just had a thought about what I see in front of me is you could take screenshots. And one of the things that we really want students to have a good sense of throughout their career in statistics is that it's about looking for trends. It's about looking for what happens regularly that we can make predictions about. So we could even take a screenshot each and every day of how students go home from school. And then we could ask students to predict on Monday, what do you think might be the number of kids who are going to go on the bus? Or how many kids are going to walk today? And we might even see trends based on seasons. For instance, maybe fewer kids walk during the winter than they do in August. And all of these noticings are so rich. They're great, again, great opportunities for students to share about their lives and about what they notice and what they can predict about the future. And there's something really wonderful about getting younger kids to think ahead about predicting, because that's going to help them in their science classrooms, and especially as we continue through our math journey, we want them to notice things and be brave and be willing to say, I think this is what's going to happen. So all of this could be done just by capturing screenshots for a whole week and having them look for patterns.
I like that idea. That's a really good idea. And I like how you said, it might change with the seasons or the time of year. So I think that's so important. And at the elementary level, we even talk about that, with our kindergartners and things. We talk about, clothing and dress during certain seasons. So then we could talk about, so if you were walking home, how should you be dressed? And so there's so many ways to apply this to all aspects of subject areas and not just this particular one. So Rachel, I'm going to send this back. I'm going to stop sharing.
Okay.
And I am going to send it to you so that you can show us what you have for us.
Very nice. Well, I love storytelling. I think that part of teaching is enjoying what you do and the story behind it. And so here on my screen, I have a couple pictures for you of one of my favorite activities that we do every fall. Now, there's a little COVID bump in this year. We're not going to get to do it this year. But every year, what we try to do is we try to get our pre-K 3-year-olds the whole way through our seniors. And we all had, we happen to be fortunate to have an outdoor space where we can all go to and sign up for different times with this. And what we do is we try to do a math project with pumpkins for all grade levels. And so we have our little 3-year-olds, they're sorting them by color and they're sorting them by size. And then together as a group, we all talk about what things could you measure on this? What things could you count? What things do you notice? And I think sometimes we don't give enough credit to the categorical data that we can collect on things. For instance, the color. What color is something? Or even for a little kid, they could talk about it as being small, medium, or large. And yes, that's kind of a blend uh, between a number idea and a word idea, but like trying to get them to do these categories here. I think it's a great way to get them engaged with this. And you'll notice we just put brown butcher paper over all of our tables, and every class that comes out adds more ideas to it. So they write down all of these like things that they've thought about, and they might add a little drawing too, because we tell our little kids, when you want to represent something, sometimes you draw a picture to help represent it.
I love
So
that. I love the record that's being recorded as they go along. That's really cool. Neat
well,
idea.
and one of the things that they start to realize too is we have all these ideas written all over the butcher paper, but it's not very organized. So we have data written everywhere, but it doesn't mean anything because we can't actually look for patterns in it if it's all spread out. And so that's where we start to bring in some spreadsheets as well. So I'm going to go ahead. One of my favorite things to do is just to collect raw data in a Google Doc, because I can give all kids access to it. And especially in our district, we're a Google Classroom district. And so a lot of the students find that they're getting really good at like sharing and adding, and they, like you said, they basically come to school having already known how to do all these things that we learned when we were a little older. But they all work together and they collect different pieces of data. And you have middle schoolers who are really like working on the idea of circumference, and they just got a formula. So, oh man, they just want to use a formula because they just learned it. But to get them back to the concrete nature of actually measuring a circumference of a pumpkin or measuring the height, there's great conversations that the kids have of, wait, is a height with a stem or without a stem? And just understanding how to articulate what we're saying in that data collection, and having everyone be on the same page so that no matter who collects the data, it's going to be pretty much the same. Well, meaning like collecting the data in the same way. So the students actually were the ones who suggested that we take radius, diameter, circumference, height, surface area. They suggested all of these options for us. And then I'll be honest with you, my middle school teachers are rock stars. Like they have the kids working on finding the average of this and trying to find the median. And I just think it's incredible. But one thing I don't think that every middle school teacher knows, or at least I didn't know this when I first started teaching middle school, is that the TI-30XS and the TI-30XS2, I was playing with my son's calculator. I had to like dig it out of his backpack, but we found it and I played around and it works on this one too. It actually has a statistics button on it. And it's incredible. Like they can actually do basically the first step of what they could do in a TI-84 graphing calculator. So a lot of people don't realize this, but over here, right next to that arrow pad, there's a button that says data. And if you click on that, you can actually clear out a list if there's one in there. And it pops up the exact same screen as a lot of us have seen on our TI-84, and we can put our data in there. And what I want to do is I'm going to go ahead and put in this height right now. And Lindsay, I'm going to do some quick typing because I did want to show how to like get this in here and work with it. But
Sure.
I'm interested in your thoughts, since this is kind of geared towards elementary through upper schoolers. Sorry, I teach in private school, upper schoolers, high schoolers. What are your thoughts on the whole pumpkin activity while I'm typing this in?
Well, first off, I love that it's pumpkins because once again, you're connecting to the student interest. And what I think is going to be kind of fascinating about this is I like that you had them come up with things that they thought was important to measure because sometimes things like how big the pumpkin is really matters. They want the biggest pumpkin, or some don't. They might think, I don't want to clean out all the seeds in that huge pumpkin. I want a smaller pumpkin. So I like that they kind of had the option of what they wanted to measure, because once again, it's what matters to them. But I also like that you're using this calculator. I think that, once again, students are very good at this kind of technology anyways. And so, we're kind of showing them this progression, but really it's like all levels can use all this technology. So it doesn't have to be this calculator is only for middle school and this is only for high school. I really think that all levels would benefit from the variety in technology. So thank you for showing so many of these.
Yeah, of course. I mean, I geek out over this stuff, and every time I find a new button on the TI-30, I'm like, oh my gosh, I wish I would have used this when I was teaching middle school. So what I've done is I put everything into that first list. And then if I hit the second button, because I want to get at that word stat, I'm going to hit the second button and then hit the data and stat button. Here, lo and behold, it's this option that I have on my TI-84. And so I can do a one variable statistics right here on my data from list one. I have a frequency. I only put in one list that I want to work with right now, and I can go ahead and calculate it. And here we go. We can talk to students about what some of these symbols mean, which sometimes I think in math, the symbols get in our way a little bit. And I would hope that they don't, because they're meant to make life a little easier. They're meant to make communication a little bit shorter. But if we can start to show them some of these symbols at a younger age, then it takes away that stumbling block when they're older. So
Exactly.
N is 17. Well, we typed in 17 pieces of data. That's why that's there. And X bar, that's our mean. And we should show them how to do this by hand first. And then this is almost like giving them the back of the book, right? Like, how many of us assign problems from a book, and we want students to have the opportunity to check their work and gain confidence and self-reflect. So that's what this can be for that. They can do all of this data and then check their work, because we can have them show their work and then back it up with this. And then we scroll down a little bit, and here's one of my favorite things. We have our 5-number summary. We have the minimum, we have the first quartile, we have the median, the upper quartile, and the max. And for those of us who are teaching box plots, box and whisker plots in the middle school, to help students start to understand about the spread of our data, this is a great tool to help them move straight into the construction of the box plot, so that they can start to understand, well, do I have a lot of data in the middle, 50% of this, or is it really kind of like hanging out on the ends? Do I have outliers, and how do I represent those? And just from visually seeing those pictures of the pumpkins, or having them in the room with the kids, they can tell if there's an outlier. And now we have a way to back it up mathematically. So I really recommend, my personal preference is, if I was back in a middle school classroom, I would be using some of these functions on here, because we don't have to wait until the kids buy a graphing calculator to play around with these ideas. They have this tool already sitting in their backpack, and we can get them used to it right now. And then when they move to that next grade level, or when they move to that next calculator, there's no fear in it. Because, for instance, oh my gosh, like, they couldn't have made this any better. I'm going to move my little Zoom bar for a second so I can grab this. TI actually said, you know what? We'll just put them in the exact same spot to make sure that kids understand that the data button with its statistics function is in the same place as the statistics button. Like, the whole point is to help students see that they move right into that next one, and the problem solving involved with it. So one of the first things that I want to stress is, it is not about rushing kids into scatter plots. not everything has to be a linear regression. There are wonderful, wonderful things you can do with one variable statistics. And in fact, as a stats teacher, I love it when students come to me with a strong background in one variable statistics, because then they're going to start to be able to look at distributions. Basically your dot plots that you were making, but with quantitative data, they're going to look at those dot plots and start to recognize if they look symmetrical. Do they look skewed, which might indicate that there's some sort of outlier there. And they can do this with dot plots. They can do this with histograms. They can do this with box and whisker plots, like I just said. And if they come with that really strong foundation in one variable statistics, then they're going to be able to recognize what types of problems they're working with, what kind of data sets they're working with, and hopefully make more educated predictions based on that. Because that's the big idea of statistics, is that we have a purpose for collecting data. We want to collect data so that eventually we can make predictions based on it. That there has to be a goal in it somewhere. And the whole goal is we want to better understand what's happening so we can make better predictions. So middle school, they're focusing a lot on one variable statistics, getting really good at understanding how distributions kind of look. Are there possible outliers that might affect our mean much more than median? Well, really not going to affect the median very much. And then what we do is when we move them on to more complicated data sets, we can add in our second variable. And this is really, now we're starting to tie it into Algebra 1. We're starting to tie it into Algebra 2, where we're looking at lines and what kind of line would fit well in a data set. So we're looking for linear regressions. Or in Algebra 2, when we're looking at nonlinear regressions, maybe this is a quadratic function. Maybe this is an exponential growth function. And there's so many rich activities that we can use with kids to help them understand these. So I'm here in the TI-84 now. And again, they wanted to make that nice connection between the TI-30 that the kids are already used and the TI-84. So the stat button's in the same place. And when we click on that, we can look at our different lists and we can edit them. And I actually took two of my things that the kids wanted to measure, and we're going to see if they're related to each other. So we took the height, and the kids often ask me, is the height related to the circumference? Well, we have a little conversation because pumpkins are a little on the awkward side, right? They're not exactly circles. They're not exactly spheres. They're in this like weird middle ground, which makes them awesome for mathematical modeling because there's no perfect answer. Depending on the shape of your pumpkins, they might lean towards one or the other, but the kids, now they have to think about all of these aspects of it. It's not just about like throwing on a linear regression and that's going to give me the answer. No, it really matters what my pumpkins look like. And so the context is important. And I think, you know, that was what made your problem so rich for kids, was the context it was coming from, Lindsay. The same thing here. Now the mathematical context of how a pumpkin looks really helps us make better decisions about what kind of model looks better for it. So I went ahead and list one is all of the heights of the pumpkins as measured by the kids. I'm going to say as measured by the kids because you have to remember, we have 5-year-olds who are helping collect this data. And while they're high schoolers, we're doing a really good job of working with them and double checking these numbers. We are not promising anything is perfect here. And that's okay, because that's an important conversation to have in statistics too, is how did you collect the data and can you trust it? Okay. So we have our list 1 and we have our list 2. List 1 is our height of the pumpkin and list 2 is the circumference. I'm going to let you in on a little secret. Because the height is pretty closely related to the diameter, and we might have heard somewhere that circumference is equal to pi times the diameter, there should be some sort of relationship, and we'll see if that's actually true. Sometimes I get a relationship from the data, sometimes I don't. It's going to be a surprise. I pulled up one of my like 6 years of data, so we're going to see how this works. But we want to see the stat plot for this. And the way that we can see that is we can, first of all, let's make sure it's on. So we go to second y equals to make sure our stat plot is on. And I look at that very first option and it says my stat plot is on. And I like to start with a scatter plot. I think it's a really good way to start with 2 variable statistics. And then you know what, but I pause here when I'm talking to students and I ask them, why is a scatter plot going to work for this? And why is it probably not going to be a box plot? And we just had that conversation with the last calculator that a box plot really works for 1 variable statistics. So do our histograms in here. So understanding what type of graph to represent it, that's what Lindsay was talking about, this visualization, that's just as important as just telling them, well, we're doing scatter plots. Everybody choose your scatter, let them just pause on this page for a moment and think about all the options available to them and what's the most appropriate. So now that this is on and we've had a good conversation, we can hit the graph button and there we go. Actually, if it doesn't look exactly this way, because some of these circumferences were pretty big, we would just go to zoom and I would choose zoom stat to make sure that everything's kind of on here. And first of all, I would just like let this sit up there for a minute. I would let this sit up there and I would ask them questions about this, like, what do you think you see? And if they say some sort of constellation's name, I'll be like, it does look like a constellation. Good for you for paying attention in science class. But they might say that they're noticing 2 groupings. And that would make sense in the context of our problem because I have those teeny tiny cute pumpkins and then I have the jack-o'-lantern pumpkins. And so it would make sense that we have 2 groupings here. And again, we're bringing in that context. Context is super, super important. Well, I wanted to show you guys, a lot of people, I think, play around with the TI-84 quite a bit. And so I'm going to pause on that one for a little bit. If you ever have questions, you can just follow us on Twitter and we'll answer whatever questions. But I wanted to bring up the TI-Nspire for a moment because selfishly as a teacher, this is the one that makes my life just a little bit easier when I'm doing data collection. I told you that I do most of my data collection in a Google Sheet because it's what my school is already using. So I share with the kids that one of the cool things about this is we can go to new and there's going to be so many options. It's like a computer. I have to really be intentional about what I want to do with this. But I ask them, you just wrote down a whole bunch of numbers. What do you think is the best option to show that off? And they'll be like, well, a whole bunch of numbers, that's a list. I'm just going to choose list. I'm like, yeah, you are, because that's what makes sense, right? And I always tell them a good list has to have a name above it. This is related to their computer science classes. If they're able to take a computer science class, they need to know that they need to name a variable. And a variable might have multiple things in it. And so we're going to name our variable. And that first one is going to be our height. And let's compare it to circumference. Now you'll notice I only have like 10 minutes left in this webinar, so I definitely don't have enough time to type all this in. And let's be real, teachers do not have time to type all this data in. So all we have to do is over here in the spreadsheet, we just highlight it, we copy it. I did like a little Command C there and I hit, oh, there we go. It thinks I'm typing. If it thinks you're typing, click out of the box, click back in. I say that a million times to students, so I've practiced that one. But we hit Control V and there we go. It's in there. It's ready to go. We're like super happy with that. because I just saved like 20 minutes and now I can talk to my kids about their favorite jack-o'-lantern design. And then I'm going to do the same thing for circumference. I just Control C to copy, Control V, and there we go. Everything is over and into my program, or into my TI software, and it's just so much more easy. It's much easier now for me to work with it. So I could look at all this data and try to make sense of it, or the TI-Nspire actually has a data and statistics page, which is, it's meant for this purpose. So the way we can connect two pages and make sure that they're sharing their data back and forth is by hitting Control Doc. That's going to give us the option to add another page, and I'm going to go with data and statistics because that's what this webinar is all about. So we choose what we think might influence our other. And here's that same graph we saw on the TI-84. But I like to tell my students that I need you to play with this. One of my favorite things about the Nspire is that up here in the escape button, if you hit Control Escape, you can undo as many wrongs as you want. And how powerful is that message that you can play around with math and it's okay if it doesn't work perfectly because you can just undo it. And I think that that's a powerful message to send to high schoolers because little kids play with math and it's beautiful. And at some point, someone made someone think that the high schoolers had to be perfect on the first try, and they don't. So Control Escape might be my favorite keyboard combo on the TI-Nspire. And so we can go into menu and we can look at that. The picture even tells you what you're doing. Like, guys, I want you to come up with like something that will pass through there that might make a prediction. Well, I think a line might pass through there. Great, there's a picture of a line. There's a picture of a line, go to the line. And then we start to talk about regressions. I don't know what I just hit there, but that actually kind of fits it. It looks pretty nice. Okay, so I did a power function right there. So I asked them to play around with different options. And a lot of students at some point in Algebra 1 or maybe Algebra 2 were told that we should look at R, and if R is a high number, then that's the right answer. And I have a good talk with them. I'm like, but let's think about the context again. So just because we pass through like a bunch of points doesn't necessarily make that the best option for us. The context of this is I have a one-dimensional height and a one-dimensional circumference. And now I'm talking geometry here, right, with dimensions. And so there should be something that I can multiply by height to get the circumference, because height is a distance and circumference is a distance, and I should be able to do this. And so we actually talk about that might make more sense. I'm not going to hit the wrong button this time, to be a linear. Now, I will point out, if you're teaching Algebra 1 and Algebra 2, you're probably using show linear mx plus b, but as stats teachers, we love the second object, show linear a plus bx, because fundamentally, let's think about how we instruct kids to draw lines. We say, go to the y-intercept and then draw the slope off of it, which is exactly what a plus bx is saying to do. Go to your y-intercept and draw the slope off of it. So I think it's fine to do either one, to be honest with you. But I wanted to give that little plug for why I like a plus bx. Now I've got two options on here. We can just click on the one that I don't want anymore and hit delete. Maybe I can. Let's see. There we go. Now it's working. So here's our linear function right here. And we like to talk about what this means and what you could predict. And do you think it even holds true if we get a bigger pumpkin? Because sometimes models work really well for a certain grouping of pumpkins. So maybe we would just have a grouping of these tiny little pumpkins and make a really good trend line, a really good prediction line through small pumpkin data. So we could make predictions about small pumpkins. And then we could make another trend line that goes through our jack-o'-lantern pumpkins so we can make predictions about jack-o'-lanterns. And so even talking about what is our population and should I have sampled all of these different pumpkins or should I have focused on sampling tiny little pumpkins and pie pumpkins? And so all of these questions about how you collect data and how you can make predictions, or you can you even say that this applies to all pumpkins? All of these are the big ideas of statistics. And so yeah, I love this pumpkin activity. I love that whether you're using a TI-30XS or you're using the Nspire, or you're using the TI-84, you know, whatever our kids have, we want to use that because we want to meet them where they are. But also we want to meet them where they are and then take them to the next level. We want to help them see what the possibilities are and what we can do with this, all keeping in mind about good data collection and can I extrapolate from this? You know, can I make predictions? Can I not make predictions? And yeah, I think that if they walk away with that understanding, we've done a good job pre-K through 12 on helping them understand the big ideas of statistics. So Lindsay, maybe you have a couple closing thoughts, but I've shown kind of my fun toys and one of my favorite activities that I've ever taught. So I'm going to hand it back over to you.
Well, thanks, Rachel. I love that activity. That would be so much fun. And I'm sure the student engagement was really high on that one. So thank you for sharing that with us. Really, we just want to thank you all for joining us again tonight. And if you get the chance, please check out our other webinars. Rachel, you were amazing. I appreciate you helping me with the data and statistics. And I hope you and everyone have a great evening.